Today, we tackle a common scenario, filtering data based on dynamic rules. How do you efficiently count items in a collection when the filtering criteria itself is a variable? Let's dive into optimizing this pattern. The problem asks us to count how many items in a list match a given rule. Each item is described by its type, color, and name. We're given a rule key, like color or type, and a corresponding rule value. Our task is to return the total count of items where the specified attribute matches the rule value. A straightforward approach involves iterating through each item. Inside the loop, we use a series of if-else-if statements to check the rule key. If the rule key is type, we compare the item's type with the rule value. If it's color, we check the item's color, and so on. This works, but it repeatedly evaluates the rule key string in every iteration. While functional for small datasets, it's not the most elegant or efficient for larger sets, as it introduces redundant string comparisons within the loop. This brute force method has a time complexity of big O of n, where n is the number of items, and big O of 1, constant time space. The key insight to optimize this is realizing we don't need to re-evaluate the rule key string for every single item. The rule key, whether type, color, or name, tells us which index to look at within each item's array. We can pre-compute this index. We'll declare a dictionary that maps our rule keys, type, color, name, to their corresponding numerical indices, 0 for type, 1 for color, and 2 for name. Before our main loop, we use this dictionary to retrieve the correct index based on the input rule key. This gives us a single, specific index to use for all comparisons. Then, we iterate through the items once. For each item, we directly access the element at our predetermined index and compare it to the rule value. If they match, we increment our counter. This eliminates the repetitive string comparisons and conditional branching inside the loop, making the inner loop body much leaner. Let's trace this with an example. Suppose our items are phone, blue, pixel, computer, silver, Lenovo, and phone, gold, iPhone. Our rule key is color and rule value is silver. First, we initialize our dictionary, type maps to 0, color to 1, name to 2. We look up color in our dictionary, which gives us an index of 1. Now we know we'll always be checking the second element of each item. We initialize our count to 0. For the first item, phone, blue, pixel, we check the element at index 1, which is blue. Blue does not equal silver, so count remains 0. For the second item, computer, silver, Lenovo, we check index 1, which is silver. Silver equals silver, so count increments to 1. Finally, for phone, gold, iPhone, we check index 1, which is gold. Gold does not equal silver. After iterating through all items, our final count is 1. This is correct because only the computer item has a silver color, matching our rule. This approach effectively streamlines the matching process. You'll spot this pattern when you have a dynamic filtering or processing rule that dictates which specific part of a data structure to inspect. If you find yourself writing multiple if-else statements to handle different rule types, consider mapping those rules to direct indices or function calls to optimize performance. The time complexity remains big O of n because we iterate through the items once. Space complexity is big O of 1, constant time as the dictionary size is constant regardless of input size. This rule mapping technique is a powerful way to make your code more efficient and readable. Try applying this pattern to the next problem you encounter with dynamic filtering. And don't forget to subscribe for more algorithm insights.